3-in-1 turbo vacuum. This apparently doesn't work. This part here. I mean, this works. I'll make it really noisy in here for us for a second. I'm gonna turn it on right here. All right. But if you watch this right here, for some reason, that doesn't work. That's all it does. I think it feels like it might be jammed. I don't know. Spins for a second and then it stops. So I think it might be jammed or something like that. So yeah, we're going to tear into this thing here and see if we can figure out what's going on with it. Let's pull this out. All right. Let's see if we can shoot it across the floor. Oh, there we go. I was thinking it'd come out differently. It's got its power right there, so there's a motor in here, we know. Set this on the floor over here. All right, and it feels like to me it feels like it has gears, because when you turn it, it's like it's little notches. Doesn't feel belt driven, because if it was belt driven it would just spin smoother. But yeah, let's pop this thing open and see if we can figure out what's going on. Ah, dig your finger. Oh, I guess there is a belt on there. I thought it might have been gear driven, but there's a belt on there. Nothing in there. A little dust. Oh, yeah, all right. I guess that was just the motor making it feel like it was gear driven, but apparently not. Well, that's a weird way for that motor to set in there. See how it's kind of at an angle? For some reason that just don't seem right. Let's see. Oh, okay. There we go. It was not pushed down all the way. My bad. Must have popped out when I popped it open. So let's take this motor out and fire this up and see if this spins by itself. Gotta grab the other half again. Plug it in. All right. Oh, nice. So let's see if this turns. Yep. The motor spins. I'm thinking you've seen that, right? That's kind of hard to see on there. Tell you what, I'll make it easier for you. We'll put that on there. And now look. Ah. It does have a problem spinning. It looked like it spun there at first. So yeah. Let's try it again. Yep, so it looks like we definitely got a problem with the motor. Isn't a whole lot going on that circuit board there. So might be something on the inside of the motor that's making it act up like that. Maybe some windings just got wore out or something. I'm gonna take that off there, pop that off again. Disconnect that. Let's see. No useful information there. There's only one capacitor on there. Could it be the capacitor is bad? Because that's probably a, I'm guessing it's a helper capacitor to get this motor spinning. I'm looking down inside to look at I'm looking at the brushes in there. Looks like they're okay. Looks like they're hitting what they're supposed to be hitting. I'm gonna have to take this circuit board off here first so so I don't break it. So I got this circuit board off here. Before I did that though, I checked out a couple things, trying to figure out exactly what this capacitor here does. And what that does is actually on this board, I'll give a close-up so you can see it, but on this board, this capacitor is labeled F1, which usually means a fuse. And I have this right here to show you. You can see exactly what happens to this capacitor when I turn this unit on. It instantly goes hot, like 200 and something C. And I think it's C. I think I had it set on C, maybe Fahrenheit. I don't remember right this second. But that's a fuse that shuts this motor off when it gets too hot. So that's what that capacitor does there. It says 60 volt, 065 for the value. So yeah, that's why this was stopping, because there's something wrong with this motor that's making this thing get really super hot real quick. And that's why it wasn't working. That's why it's not spinning. And so I cut off some 4 spots here that held this back cover on. I don't know if there's going to be anything we can see, but I can pick this. I haven't took this apart yet, but I figured out how to do it. But I think maybe not. Broke the tip of that off in there. I started it coming up, but maybe not. I didn't pull it all the way off, but I just started it because I wanted to do it on camera so you can see it too. There we go, a little bit. Yeah, you can see it's coming out now. You know, like motors, they just have the metal pieces bent over it to keep it closed. And of course, you can't just buy this motor, because I looked it up and you can't do it. So now there's brushes in there that we have to try to get out of the way instead of breaking them off. There we go. So you can see the brushes, they still look pretty good. You got one on this side right here, and then you got the other one over here. They just separate like that to go around that part. So the brush is still looking in good shape. A lot of it there. I probably won't be able to get that out unless I pry that off there. But yeah, these again, I'll put some close-up pictures up there, but these points right here that the brush is right up against, getting some light here. You can see anyway that these are split, so there's like 4 sections in there, and in between each section is like a burn mark from 2 burn marks, one at the top of the brush and one at the bottom of the brush. Each one of them have that, so I don't know if that's filling in carbon from the brushes into those little lines there, and that's making them short across. But it always just starts and then stops because it's getting too, something's getting too hot. But I'm gonna have to pry this off here. Yeah, so there's no buying just the motor, so there's probably not a whole lot we can do with this. Good way to jab myself. Yeah, that's pressed down there pretty good. I'll have to try to get that off, and then we can get this out, but I don't know if it's gonna help us at all, but I'll try to get it out and show you what's going on, and I'll get a better shot of what these brushes look like. But, all right, I'm back with some information. I took some time to take out one of these brushes, okay, and I'm going to show you the reason why these fail. So if you own one of these, it's gonna fail, and I don't know if they did it on purpose so they can sell parts for them or sell more of them or what, but somebody at the factory screwed up when they ground the curve in the brush. So I'm just gonna draw a real crude drawing here for you. Okay, so the motor, we have the shaft that it goes around. So I'm just gonna do a motor like this. Here's the shaft that it goes around. Okay, this is what the brush hits up against right here. What they did, now here, let me do it this way. Here's the shaft. I'll do it this way first. Here's the shaft sticking straight up like this, so it's pointing upward. The brush should be ground like this. Have that in there like this, so it hugs that shaft, and it wears down this portion right here exactly the same as this spins around. Okay, now you know where I'm going with this. This is where the factory screwed up, and I don't know if it's on purpose or not, but whoever did it, they screwed up and they put that ground section the wrong way. So now if we look at it this way with the motor laying like this, we're going to take this piece right here and bring it over here. This is the correct way. All right, this is the wrong way. What they did is they put this brush over here like this and cut it like that. So you see what I'm saying now? So these points right here are digging in to the edge. All those little lines, they're not sitting up smooth around the shaft like they should. It's only those points right there that are digging into this shaft, digging grooves right there as these points hit that shaft right there. So it's not getting a nice smooth contact on there to make it run perfect. So with that happening, these edges right here are digging in to the spaces, and I'll put pictures up here as I'm talking. They're digging into these spaces that are in here. There's, what I say, 4 earlier, but there's actually 3 of them. So there's 3 spaces to where, like this, to where these little copper contacts here are close to each other. And those corners right there are digging into those spaces, and that's what's causing the motor to stop, because it dug into there, and now the brush, the corners of the brush is dug in there, and it's making that capacitor here, our fuse, heat up instantly because the motor's not spinning. If the motor was spinning, this wouldn't heat up. So, and I'll show you this one right here. I'll take a picture of this, and you can see where, you can see what part of this brush is actually hitting on that contact in there, and you'll tell by the way it's scraped on there that they put it in there the wrong way. They ground the angle in there, this angle in these the wrong way, causing these to fail. So if you have one, break out your wallet, because you're going to be buying a new head, because these motors are going to be junk. I mean, they're not going to work. They're not going to last. If yours lasts long enough to grind this the right way, as the motor goes around, you're going to be lucky. But yeah, otherwise it's going to fail just like this one did. So that's what I come up with. It's a factory defect, purposely done or not, I have no idea. So I can try to grind these the right way, and I might do that just to see if it works, because you know, this stuff is pretty soft. So I might just take a file or something and do it just to see if I can get it going again. And if that happens, I'll add it on right after this, right after I get talking, of course. But yeah, so there you go. So I did a little work, decided to try it to see if I could file these kind of close to matching the diameter of this. And I got a picture here I can show you of the final result of my filing. And I had this really tiny little file that has the round edge on one side, it's got flat on the other, and that seemed to work perfect just to get in there. It was like the same diameter as the shaft in here. So that's one of them. I'm gonna do the other one, and then we're gonna try to put this thing together and see if it actually works. So now I have it ground this way right here. So we got the shaft, now we have a nice round indent in there. So as long as I didn't ruin this, taking it apart and trying to pry that off or anything, we'll see if this works once I put those in there. You might be asking what these things are. These are just spacers, it looks like. They're circuit board material, that's what it looks like they use. Top of my head, I can't think of what the name of this stuff is, but yeah, I just pulled them away just so I can get in there, but these actually get pushed back down in there like that. So, and I did take a knife, a real brand new and a real sharp one, and I went in between the lines to get all the dust and everything out, and I blew it out and everything. So now there's no short in between any of the three surfaces on there. So let me get to this other one, and we'll put this thing back together and see if we did any good. See if we saved some money. All right, folks, got this back together. Got my tape on there. Cross your fingers. Let's see if that did any good. I actually did the other brush, like I said, and the shaft on the motor. I took some really fine sandpaper and kind of went around that shaft to get those black marks from the brushes digging into it. Just lightly, not a whole lot, because there's not a whole lot of metal there. So you don't want to sand it all away. So I got the thing plugged in. We'll try it like this and then see what happens, and hopefully it'll work, because then we can get the thermal camera on this again and see if it gets just as hot. Either it'll go or it'll burn up right in front of our face, one of the two, right? All right, cross your fingers. Here we go. Fail. Before we go, I got something interesting to show you. Got the motor with the piece of tape on there, and I have it hooked up to my power supply, and the meter is reading the voltage coming from the power supply. And this motor will run to a certain point, and then all of a sudden it'll vibrate really bad, and then it'll cut out. So it almost seems like the bearings in here are bad, you know, from the force of being mounted in there and having the belt wrapped around the pulley here, and it just kind of wore the bearings out. This is a guess, but I can show you. Watch this. This is an 18-volt motor, so I can go up to 18 volts, but I haven't been able to get up there yet. So I'll hold this here, and you can see the tape, and hopefully you'll be able to hear it, because it'll be smacking the table. And you can see that it does run. I'll just start cranking it up, and it runs really smooth right now, but when it vibrates, I can feel it in my fingers. So it's running smooth, and you'll be able to tell when it stops running smooth. Now if I just leave it right there, it might run for a while, but then all of a sudden it'll just get to a point to where it'll vibrate, and then it'll stop. So then I'll turn the voltage down. So that's 13 volts, still going strong. The capacitor fuse is not getting hot because it's not cutting off the motor. So let's go up a little more. It usually cuts out right in here. There you go. And when it does that, boy, does this smell like it's burning up. So I don't know really what's going on, but that's a guess. And I turned the voltage all the way down. This smells like it's burning, you know, smells like electronics burning. But once I turn it down and I can just go right back up again. So our capacitor here, our fuse, is doing its job, but something is vibrating, letting loose, and then it starts messing up the motor. Hear that? It's wanting to cut out now. There it goes. You can always tell when it cuts out, and then you get this big old whiff of burning electronics. So there is something wrong with this, and I believe it would have to be with the torque on this, and it's just wearing this little poor motor out, you know. So, but yeah, it's an 18 volt. The whole thing is 2 amps, I guess. That's including the other part too, but on the power supply, it's not really reading any amperage until it vibrates, and then the amperage just spikes. Just another little quick thing I wanted to throw in here. Got the old motor, got the new head with a new motor in there, and I want to test the ohms reading on this new motor compared to the old one. And right now we see 13 ohms. It goes up and down just a little bit, depends on how much you play with it or whatever. It's probably the fault of my meter, but yeah, you move these around and it but it comes out to be like 15, even though my meter's a little flaky right at the moment. Yeah, so it's about there. So now I want to pop this one open and see what the new one measures, just for comparison. So let's slide that stuff aside for now. Brand new, not even open yet. Now, let's see what this one measures. Let's get our little clips over here. This wasn't supposed to take but a couple seconds, but you can see things never go the way you want them to, so it takes a little longer. I'm trying to clip that on my probe. The clip is not as big as the probe. There we go here. Get that in view. All right, so that's the new motor. Let's see if I can wiggle this around and see what it does. It's about 18, 17. I just want to make sure my meter is doing what it's supposed to be doing. There we go. Now it's back down. It's down to 13 like the old one. So in that case, there's no difference in the readings and the windings. So we didn't learn nothing there, except that they're the same. And yeah, I can wiggle this one back and forth, but this one I can't. So yeah, it's definitely the bearings wore out on here. Yeah, that's it. And that's because of the way it gets pulled on when this is digging into the carpet. You have this belt and this thing, it holding down tight, you know, locked in here, and then it's just forcing this part this way, you know, and this gets caught, so it you know, kind of creates a more tugging and stuff like that. So yeah, that looks like that's what goes bad is the bearings in there, and that's why our old one vibrated when it got to certain, you know, speeds or whatever. We had the voltage up and down, but yeah, and that's why when it goes down really low, and I showed you that part in the video, that's because it vibrates in the bearings there, and it just slows this thing right down. So yeah, there's the problem. All right, this took a lot longer than what I expected it to, but I just wanted to see if the ohm readings were the same and find out if it actually was the motor windings or the bearings, and it is the bearings. We will see you in the next one.